Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to everyone. And today, my name is Farhan bin Mohamed, and today I'm going to moderate the session, the second session of the Network Security webinar series in conjunction with the World Standards Day and IEEE Day. So, gladly, basically, being a moderator for today. And this session is co-organized by Malaysian Technical Standards Forum Berhad, MTSFB, IEEE Malaysia Communication Society, and Vehicular Technology Society, or we known as ComSoc VTS Joint Chapter, and IEEE Computer Society Malaysia. So for today, we have an upcoming great researcher, Dr. Faiz Zaki, who will be the speaker for today webinar series, titled "Increasing Network Visibility for Enhanced Network Security Monitoring." So let me brief you a bit about Dr. Faiz Zaki. Dr. Faiz Zaki, are you okay today?
Yep, I'm fine, good, feeling great to
Right.
join the session. Alhamdulillah.
Alhamdulillah. And you are in UM right now, right?
Yes, I'm actually in UM. I'm serving as a senior lecturer here lah. So today is the second day of the semester kan. So
Yes.
after 2 years of pandemic, so 2 years of nobody is around.
Mm-hmm.
Today the faculty is full of students, full of people. So yeah,
Great to be back, right? Great to be
yeah,
back,
yeah, yeah.
actually.
Everyone's pretty excited actually.
Okay. Is it okay if I give you an introduction of your background a bit?
Yes, please go ahead.
Okay. So, Dr. Faizaki obtained his Master of Science, Web of Science and Big Data Analytics from the University of College of London, and PhD in Network Analytics from University Malaya. He is currently serving as senior lecturer at the Department of Computer System and Technology, Faculty of Computer Science and Information Technology, University Malaya. His research interest focuses on the intersection between big data analytics and computer networking. As such, most of his work revolve around network analytics, such as network traffic classification. Currently, his research direction is steering towards producing real-time network analytics using technologies such as edge computing and federated learning. Maybe Dr. Faiz will explain a bit more about his field. And Dr. Faiz also holds several professional certification in computer networking, such as CCNA and HCIA. CCNA is from uh,
Cisco,
Cisco, and HCNA is from Huawei, right?
Huawei, yeah.
And beside being an active member of the IEEE and ACM. All right, so the title of the talk today is Increasing Network Visibility for Enhanced Network Security Monitoring. There's a lot of Facebook in your abstract, but I leave it to you to explain a bit about your talk. So now I welcome Dr. Faiz to give his lecture today. Lecture or seminar today.
It's a talk. Okay, okay.
Right.
All right,
Full
all
of
right.
this
Hopefully,
message.
yeah. Hopefully, it won't be a lecture lah. Hopefully, it won't be a lecture.
Okay. All right.
Okay. All right. Thank you, Dr. Farhan. Assalamualaikum. Good morning, everyone. My name is Faiz. So, I'm from University of Malaya, actually, serving as a senior lecturer, as what Dr. Farhan has just introduced me just now, at Department of Computer Systems and Technology, Faculty of Computer Science. All right. So my background is primarily in computer networking. Okay, computer networking. So if you are asking what is a computer network or what computer networking is, then we actually connect computers together. So that's what computer networking is generally about. Okay. So the ability of computers to talk to each other, I mean the ability of you using your smartphone today, your internet today, those are all directly related to computer networking. All right. So to be more precise, I'm actually working on network analytics lah. So network analytics ni it's a sort of combination or a meeting point, common point between big data analytics and computer networking, right? Because if we are speaking solely on computer networking only, then maybe it involves a lot more about routing, computer switches, all the networking devices. But uh, we can't deny that today there's a lot of data, and that includes network data as well. So we incorporate or we combined big data analytics into computer networking, and that's where we get network analytics. Okay, so that's what I'm working on lah. At a high level, that's what I'm working on. Okay, so for today's talk, um, I'm actually going to share about a part of my work, which is network traffic classification. Network traffic classification is where we actually try to determine the type of application being used on the network. We'll go into that later on. But given, you know, okay, first of all, we will start at the very basic level. I'm sorry about that. Okay, so when we use the internet, right? We use the internet regardless whether it's from the smartphone or from the laptops, iPads, tablets, desktops. Whenever we are connected to the internet, or whenever we are doing something over the network, um, you might be wondering how your data travels from one computer to another. For example, you are sending a WhatsApp message, or even this video. You might be wondering how you are able to see my face or listen to my voice, even though you are located somewhere else. Maybe you are located in another state in Malaysia, for example. For example, Dr. Farhan is in Johor, I suppose, UTM. So I'm in KL, University of Malaya. So how does Dr. Farhan manage to see and to listen to me? Right. So that's where computer networking comes in. And what happens is um, there's a network traffic, a computer network traffic. So this so-called traffic is what is transporting my voice, my video, my face over the network to Dr. Farhan's network. All right. So it's similar to the road traffic that we face every day. All right, where if you want to go from location A to location B, then we have to go through traffic. So it's similar in computers as well. All right, but the thing is, maybe I have a single slide actually. Maybe if the technicals can actually put on the slides. Yeah, all right. Okay, so the thing with network traffic is we don't really know what actually generate the network traffic. Kan? For example, if we take back the example of road traffic every day, kan? So if we can pick one of the cars on the road, it's impossible that we know the original location and the destination just by picking the car. We need to somehow ask the driver, something like that, right? Or else it's impossible for us to know from where the car is traveling and to where the car is traveling. So similar with network traffic, if we are given a sample of network traffic, it's impossible for us to know what application generated that traffic, right? Because these network traffic, they don't come with name tags. All right. So when you capture network traffic from your computer, um, there is no indication of what generated the traffic, whether it's from Facebook or even it's from a HTTP application or it's from a SSH application, anything. We don't know at from the traffic itself. We cannot know. Okay, we cannot know. But it's actually very helpful if we can label or if we can classify this traffic. Why? Okay, why do we need to know which application actually generated that traffic? Or in other words, the traffic is the traffic comes from which application? Sorry, all right. Because it's helpful to put on maybe policies, or maybe if we want to say that you cannot view Facebook in the office. Okay? You cannot view Facebook in the office. Or you cannot, or maybe you want to analyze how many people actually view Instagram or use Instagram in your network, for example, things like that. Or from the security point of view, since we are in the network security week, right, network security webinar series. So from the security point of view, we can actually track which application is on our network. Maybe if we have a malicious user on our network, then we can actually track which application is actually compromised. Okay, for example, we have captured the compromised traffic, and we need to know which application is the culprit. So if we want to know which application is the culprit, then network traffic classification comes to the rescue. Okay, so now what's left is, how do we want to know which application generated the traffic, right? Because we have established the definition, we have established the problem and the need for network traffic classification. So now the only question is, how can we put on the labels? Since I said that initially we don't have any way to know which application generated the traffic. So now how can we label them? How can we classify the application that generated the traffic? Okay, so there are a few ways. Some are simple, some are not quite simple. Okay, so the simple ones include maybe IP address matching. All right, IP address matching. So for example, remember that I said that maybe in the office, the management, the administration don't want to allow you to visit Facebook. So the simplest way is to actually log on onto the router and just put in the Facebook IP addresses, all right? Then filter the outgoing connection, meaning if the outgoing connection is supposed to be heading to Facebook or is using the Facebook IP address, then we block it. Simple. But the thing with IP addresses is that it's actually not consistent. Okay, so in other parts of the world, the IP address for Facebook might be different. Okay, because Facebook is not using a single IP address, obviously. All right, for availability reasons, Facebook is not using a single IP address. So what happens is that we need to know the entire IP address space of Facebook throughout the world in order for our solution to be the most consistent. So this is a problem. And anytime that Facebook changes its IP address, which although unlikely, it might happen, which although very less likely, but it might happen, then we need to update our filters as well. Okay, so that's one problem. Okay, so another way is by using port. Yeah, port. Port is similar to IP address, but it's a more generic way of classifying traffic. For example, if you are using a HTTP application on your browser, then the port is 80. Okay, so if you are using HTTPS, which most web systems are using nowadays, so the port number is 443. Okay, so if we were to if we were to receive a network traffic holding the port number 443, automatically we know that it's a HTTPS traffic. Simple. But the thing with port is, one, it is a very high level view of the traffic. It's very coarse grained. For example, if the 443 port, right? The 443 is just labeling as HTTPS. We have millions of web systems on the internet using HTTPS. So although it might solve partially the problem of network traffic classification, but it's only at the coarse grain level, at a very high level. All right. So if I, as a network security administrator, I want to filter port 443 for example, I want to limit port 443 into my network, then all applications using HTTPS would be affected, right? So all applications using HTTPS would be affected by that policy, which is maybe undesirable. Again, because you might want to block only a single application, but since you're using the port 443, then all applications utilizing that port would get affected. Okay? And another problem with port is that most modern applications are not using the standard port. All right, because we have a standard port allocation, all right, defined by a formal body, lah, right, defined by the IEEE to be exact. It's a International Assigned Numbers Authority, IANA. So this authoritative body, they actually assign an allocated range of port numbers to common applications. For example, HTTPS, you have 443, HTTP, you have 80, SSH, you have 22, right? And all other things. But the thing with modern application is they don't really adhere or they don't really follow this standard port assignments anymore. Okay, so we call it dynamic port assignments. So with dynamic port assignments, if you were to rely on the standard port assignments earlier on, then you won't be able to classify traffic accurately because majority of other applications are not following that standard or that rule anymore. Okay, so for example, a new application B, a new application named B. So this application B may not follow the port assignment 443 anymore. It can use any other port numbers. So this is a problem because there are numerous other port numbers, and since modern applications don't typically follow the port assignments anymore, it's difficult for us to build an accurate classifier. All right, so that's two limitations or disadvantages of using port numbers or port-based classification. All right, so in fact, there is a study by researchers claiming or demonstrating that port-based classification is only able to achieve up to maybe 70% accuracy, which is pretty low to be honest. All right, so 70% accuracy for today is pretty low because we need highly accurate classifier in order for us to put on appropriate security policies. Okay, so that's
Dr.
port.
Faiz,
Yep.
yeah, I just wondering, you say that for the modern application, you meant that we no longer like use like 80 port, 8080 and 443 like for specific application. Right now,
Mhm, mhm.
basically you can dynamically, like for example, you can use different port 20 and plus any
Yep, yep.
ports for all the even HTTP, HTTPS and so on.
Yes.
So there goes my basically my notebook in 2000. So because we learned about that earlier, right?
Uh,
So there are specific
Because
ports for
we
applications.
what we know about port is, Dr. Farhan,
Yeah.
we know that there's I mean, based on the textbook lah kan, textbook punya knowledge is there's a three categories of ports. One is the well-known ports kan. Well-known
Yeah.
ports is the port 80, port 443, and then
Yes.
there's a user-registered port. User-registered port
Mm.
is orang kata a specific port registered by certain applications lah. For Skype, example,
Mhm.
for example. So this famous application, well-known applications. And then
Mhm.
we have the dynamic port.
Mhm.
This dynamic port is the one that's being used by the majority of modern applications, because
Mhm.
one
Okay.
is um, to actually exploit this fact lah. I mean, if they use the normal punya port allocation, then it's easy for security appliances, network security appliances, to detect them. So
Yes, yes.
if they use random ports, then although we can still detect them, but it's more of a challenge lah. Kan?
Mm.
Of
Okay,
course we
okay.
can detect them, but it's a bit more challenging because we need to keep track, we need to
Mm.
find out further compared
Mm.
to the traditional ports. Kan? Traditional ports ni, You nampak je port 80 then confirm HTTP. Kan? Confirm lah HTTP.
HTTP
Kan?
or FTP lah usually being blocked.
Yes, 22, 23, 21.
Uh,
Kan? So that's a typical punya port. But developers nowadays pun they are more advanced. They are more advanced than apa ni previously. So even more so for malicious punya developers, adversarial punya developers kan. If memang they intend to cause network security punya violation or something, memang niat tu bukan suci murni sikit kan. So it's obvious that they will use some other port numbers kan, because it's very straightforward to circumvent or to have orang kata apa an alternative lah untuk apa nama ni, untuk elak this classifier kan.
Yes.
If the classifier is only using the port numbers, only using the port numbers. So that is the reason, Dr. Farhan, there's a very prominent study, a very seminal study lah kita kata, by the researcher. I think it's by Andrew Moore kot, the name if I'm not mistaken lah. So he's a very prominent researcher. So his research actually proved that port number is no longer reliable. I mean for this purpose lah, for this purpose.
For this purpose lah, classification purpose.
Yes, for this network traffic classification purpose, port numbers are no longer reliable. If used apa ni on its own lah. If we rely solely on port numbers to classify our traffic, then I'm sorry to say that is very, orang kata, the reliability is arguable lah. It's arguable. Alright. So a standalone port-based solution ni, based on the study, it can only achieve around 70% je. If compared to other existing studies using other technologies, it's pretty low lah. It's on the lower end of the spectrum lah. Kan?
Okay, Dr. Zaki, Dr. Faiz, okay, continue.
Okay. No problem. Please interrupt if ni lah.
Yeah, just
kan?
okay.
Alright. So we have covered IP address punya classification and port-based classification, and we have figured out that these two approaches is somewhat unreliable given the fact apa ni today's punya very complex punya development lah. Alright, we have very complex applications these days yang use all sorts of development punya strategies lah, architecture strategies. So if the application tu memang intended to be malicious, then these two factors, IP address and port numbers, will definitely be masked, or they will use other non-standard numbers lah. Right? Okay. So when researchers or when the people working on this problem figured this out, they said that, okay, so how can we make sure that this problems is fixed, or I mean, what are other alternative solutions? So they come up with a payload-based punya classification. So payload-based ni, it's very interesting because it's highly accurate. It's very, very accurate. In fact, most commercial solutions by network vendors out there, Palo Alto ke, Cisco ke, Huawei ke, whatever lah kan, HP ke, almost majority of the vendors out there, they utilize payload-based classification. Okay, so what's payload-based? So you know that you are sending data over network in the form of traffic. Okay, so if we go deeper into the traffic, you will have packets. So a collection of packets make up the traffic. For example, in the real world, a collection of cars on the road make up the traffic. So in computer network, a collection of packets make up the traffic. So inside that packets contains your data. If you are sending an email, then the content of your email is in the packet lah. If you are communicating via video like we are doing right now, so our video is actually encoded inside the packet. Okay, so that involves a little bit more technicals lah, but it's sufficient for you to know that your data whatever it is encoded or it's put inside the packet. Okay, so these vendors or this the people working on this problem, they say that what if we look into the data? So if we look into the data and we find that the data is video, then we can actually label it as video. Or if we look into the data, then there is a maybe indication of the video is from Facebook, because it's your data kan. It's it's your raw data inside there. So memang typically or not typically. So um, um, of course, everything that we need to know should be in the data, whether it's from Facebook, where you're from, what you're doing, everything is included in the data. So these people, they say that how about we use the data again? Because we can straight away know what is inside, then we can label it without any problems. Okay, so they come up with this payload base using what they call as signatures. So if there is a certain common, yeah,
I can hear there's some
yes, I think
okay over there.
there's actually apa ni, they're testing the fire alarm. Hopefully they're testing lah. Hopefully there's testing.
So hopefully it's okay over there. Right. So you
Hopefully they're testing.
Yeah.
Okay. All right. So I apologize if it's disturbing lah. Sorry, I can't actually do anything about that. I'm sorry.
Yeah.
Okay.
Mm.
Okay. So they come up with signatures, Dr. Farhan. They come up with signatures. So if they open up the data and they find this specific signature, then automatically it's labeled as whatever that they have labeled lah. If Facebook ke apa ke. Okay. So everything is good. Okay, it's accurate, and then it can be used anywhere in the world because the data is the same, of course. You are located in America ke, you are located in anywhere else ke, any continent in the world. If you're communicating through Facebook, then your data is orang kata structured as a Facebook data lah. So if you were to be able to open up the data and look right into it, then you can actually see the Facebook data. Simple. Okay, but there's a problem. There's also a problem. The main problem is privacy. Privacy. Because since they are looking right into the data, so they can actually see what you're doing. All right? If you're talking to someone over email, for example, then they can look over the email. Kan? You might say, oh, is it encrypted kan? Is it encrypted? Biasalah. Majority of the traffic nowadays, I think more than 80% of traffic, based on the latest report, has already been encrypted. Okay, but what we don't know is vendors, Cisco, Palo Alto, all these firewalls, semua vendor ni, they can actually decrypt our traffic. So they can actually decrypt our traffic using their own proprietary technology lah. Technically, they use their own TLS certificate, and then they open up our encrypted traffic, and then they look what's inside, they classify, and then before they let the traffic go, they encrypt it back. So ethically, it's not wrong lah kot, sebab they encrypt it back before they let it go. Kan? They encrypt it, they buka and then they tutup balik. Right? So okay, fine, but diorang dah buka. So if we cannot like blindly, trust that they don't do anything lah, kan? Because if they manage to open, then there is a risk. Alright, then there is a risk. If they manage to open, then there is a risk. So there is this privacy concern. And number 2 is they need to maintain an updated version of the signatures. They need to maintain an updated version of signatures. So signatures ni they need to store somewhere. Right? Maybe they need to store in a database ke, somewhere ke. So there comes another issue of storage and updating lah. So it requires constant human intervention to make sure that the signatures are well updated and we have the latest signature. For example, if we have a new application coming up in our network, then it's impossible for us to know lah, because we don't have the signature yet. So we need to create the signature, and then only then we can classify it. Okay, so that's two main limitations of the signature based, of the payload based punya classification. But despite the limitation, most of the available commercial products out there, right? In fact, even in University Malaya, we are using Palo Alto actually. Um, Palo Alto actually utilizes this technology. It classifies based on the payload, right? But from the research punya point of view, the research community, they realize that this is a problem. Although that most people on this planet don't really care about it, because they don't know good. They don't know that these technologies can actually see what they're doing. Despite any form of encryption, we can actually decrypt it back. Given we have the necessary technologies, we can decrypt it and we can encrypt it back once we are done doing anything with it. So the research community realizes that this privacy issue is a big issue. It's a big issue. So they figure out we need another solution. We need another solution that don't tamper or don't actually touch the payload. All right, we don't want to cause any privacy concerns. So what they did was they realized that network traffic actually has a certain statistical characteristics. Statistical characteristics. For example, a Facebook traffic actually travels in a typical, for example, the time spacing, the time taken for a Facebook traffic to travel is similar to other Facebook traffic and is different from other applications. So this kind of characteristics. For example, another example would be the size of the traffic, the size of the packet. Maybe a video traffic is larger than a non-video traffic. So they figured out, if we can actually use these features, these characteristics to classify traffic, then we're good to go. We don't actually tamper with the payload. We don't know what you're doing actually, but we can know at a certain level, okay, based on the characteristics. So that's what they did. They actually analyze the traffic for characteristics. For example, the traffic size, the header size, the inter-arrival time. Inter-arrival time is the time taken between consecutive packets. All right, consecutive packets. So we have 10 packets, for example. So the time taken from for packet 1 to go through and the time taken for packet 2 to arrive. So that gap in time is measured. So we figured out that this gap in time is actually a unique characteristic for each application. Okay, so since we have found out that we can actually use these statistical characteristics to classify traffic, then comes another problem, kan? Another problem that is, can we make it a little bit more automated? We know that we can use statistical, but how can we classify or how can we make use of these statistical features to classify or to build a classifier? And then that comes the latest technology, which everyone is talking about today, which is machine learning. Or machine learning ni banyaklah algorithm there. It has a lots of algorithms, deep learning included. So all these algorithms is actually utilize one main thing, which is features. So in our problem, in our domain, we can actually utilize these statistical features as inputs to machine learning classifiers. Kan? Okay, so now we are sorted lah. Kita ada, we can make it work without tampering with the payload, and then we can also make it work without relying on the unreliable techniques earlier, which is port-based and IP-based. So we are solely relying on statistical features. Okay, everything is good, no problem. People's been using it for quite some time. There are hundreds and thousands of research papers talking about it, no problem. But as time evolves, people will always want more. Typical lah. So network security administrator ni, they say that, okay, we can actually classify application protocol, no problem. If you want to differentiate between HTTPS, SSH, FTP, no problem. It's very easy. Very easy. Okay, and then we can also classify the application types. For example, videos. We can classify video traffic, no problem. We can classify email traffic. We can classify game traffic. Okay, the generic punya categorization kan, no problem. Okay, and then when we have this latest development in network security kan, we have the next generation firewall. Okay, if you have heard of it lah, next generation firewall have been around for maybe, I don't know, maybe 5 to 10 years maybe. Okay, but it's the latest punya technology lah in terms of firewall, next generation firewall. So next generation firewall ni, what's different about it is dia ada application level classification. So protocol and type level no problem, but it gives us another issue because it's only generic, very generic. If you want to put policies on it, then everything will get affected. Kan? Macam I cakap earlier tadi lah. We want to block Facebook je, tapi disebabkan we used 443, so everything that is using 443 is affected. So they come up with this application level with they have the domain context lah, right? So they can classify Facebook, Twitter, Gmail, Google, TikTok, Twitter, Instagram, anything that is application level. Okay, so once this next generation firewall being introduced ni, so people are all rushing towards application level punya classification, kan? So over the years, and then we actually found out, my group lah kan, my group. Then we found out that, okay, application is there, but what if we can go even deeper than that? So that's where we come up with the application service pula. Application service is what you are doing inside Facebook itself. Are you commenting inside Facebook? Are you liking inside Facebook? Are you posting inside Facebook? So we want to differentiate these different activities done inside a particular application. So that's the application service level. Again, application service level is the most granular lah. So we can actually pinpoint, or we can actually implement policies at that very granular level. At that very granular level. And we are still using the same method, which is the statistical features too. But there's a different kind of features lah. But maybe we can save that for another day lah. We can save that for another day kan, because it's a little bit more technical than what we are discussing right now. So we are discussing only the surface level. So
Dr. Faiz, so basically all these are based on the statistics.
Yes, based on the statistics. So just solely based on the statistics, not only I can know that you are using Facebook, I can actually know what you're doing is precisely in that Facebook punya application. Mm-hmm. Are you liking? Are you posting? Or if it's in Twitter, are you tweeting? Are you retweeting? Kan? So this is very helpful to the network admin kan? Network administrator. Kan? So if we detected a malicious user, we can actually know what this user is doing. Mm-hmm. Based only on the statistical. We tak payah temper the payload anymore. Because if you are using the payload, yes, memang we boleh buat, no problem. Because in payload memang kita boleh detect the URL ke, the apa ke kan. But if from the statistical point of view, it's actually very difficult. So if we can look at the slides, maybe we can put up the slides again. Ada tak the slides again? The supporting slide tu. Yes. Okay, tak apa.
Yeah.
Okay, it's fine. If you look at the slide, actually, there are four graph kan? 4 figures lah kan. That's actually the payload size. Payload size saja, bukannya payload content, payload size saja. So you can actually see, despite slight similarities lah. Despite the similarities, there is actually a slight difference between Facebook comment, Facebook post, Facebook react, Facebook video. As you can see, the distribution is a bit different. Kan? So we can capture this slight difference in distribution to detect what the traffic is. That's where we are at now. That's where we are at now. Because if you see,
can you explain a bit about the basically the labeling of the graph?
Okay, so the y-axis is the size. Okay, the
Yeah.
y-axis is the size, and the x-axis is the time, which is ni lah, the packet
Mhm.
captured over time lah. The packet captured over
Okay.
time. So if we look at
Mhm.
Facebook video, for example, most of the sizes, the packets are distributed at the lower end, kan? Dekat this apa ni? The 0 bytes to ni lah the earlier punya time frame, kan? But the difference is they have a sudden surge of packet size, payload size, because that's how video is actually transferred to our network. Video ni is not transferred continuously macam tu. The video traffic is transferred in surge. Maksud dia in groups lah. Dia hantar sekali, boom, lepas tu dia stop kejap. So dia hantar sekali lagi, boom, so dia stop kejap. So that's what you are seeing lah on this graph. The different distribution between the application services. So we actually capture these differences, and we can actually train our machine learning model to actually differentiate between the application services. And in fact, Dr. Farhan, application services tu rasanya dah granular dah. Okay dah, dah granular dah. But we differentiate lagi. We actually,
Yes, yes. That's why I thought that's already
we,
enough. Yeah.
we differentiate lagi. We say that we have intra-service application, I mean intra-service pula dah. Intra-application services and inter-application services. So intra-application services is the one that you see on the slide just now. Different services within the same application. But inter-application services is the same service, for example, Facebook comment, but on different applications. You know, kita ada banyak applications that have this comment feature, kan? Kita ada Facebook, we can comment on Facebook. Lagi apa lagi? Twitter, we can also sort of comment on Twitter. Instagram, we can comment on Instagram. So these different applications, they have similar services. So we compare pula services between different applications ni. Okay, what's the difference between Facebook comment, Twitter comment, Instagram comment, and TikTok comment? So that's inter-application services. So we categorize the two different services ni pula, inter-application and intra-application. So that's the most granular lah. At the moment what we are working on, and actually what the research community is working on is up until to that level je. We don't know if we can actually move further than that, kan? Tak tahulah if one day we can actually move further than intra and inter application services, kan? But what I'm trying to say is we have moved a long way from using or from relying on the traditional port based or IP based classification, and then moving to payload based, and now we are using the statistical punya based classification using machine learning. All right, despite the commercial vendors or the commercial products these days still put I can say macam tak adalah nak kata heavy reliance, they are using AI juga, but we cannot deny that they are still using the payload based classification because of its accuracy and because of the fact that they have the capability to do it, because they can actually decrypt your traffic, because they are huge companies, kan? They have the means to actually intercept and decrypt your TLS traffic. Alright, but there's actually ni lah, ada privacy concerns lah. Okay, because we don't really want to tamper with the payload, kan? We don't really want to tamper with the payload because it's rather unethical lah, kan? Unless it's we call it as lawful inspection. Lawful inspection ni is what the court orders lah, kan? Kalau government they can actually based on the court orders, okay, perintah mahkamah, they can actually take our traffic and see what we are doing in it. It's called as lawful inspection, LI, lawful inspection. I'm sorry. Okay, but we are moving past this, and the latest state of the art is using statistical features. Alright, in fact, even the paling latest punya work is actually moving away from statistical features and using deep learning. You know how deep learning works lah, kan? Deep learning ni you don't have to create the features per se lah, explicitly creating the features. So other one side of the research community is moving towards the utilizing deep learning lah. But for the most part of it, they are still working on the statistical features ni. Okay, so that's generally how we increase the network visibility lah. We want to look into the network. We want to know what you're doing, but we try as hard as possible. We try as the best that we can, not to actually you know, take it literally from you lah. Maksudnya take it from your payload. But if you are speaking about privacy, um, privacy is still tempered lah in some way or another because we know what you're doing. It's just that we don't have the literal data of yourself too. That one we don't have. Okay, okay. It's
That's
11.
yes, yes. That's quite interesting. Yeah, because
Yep, yep.
the organization still at the what you call Mr. Nordian Ramli said something about the default port, still using default port, for example, in certain
Mm-hmm.
organizations. And now we move way forward, right? Ahead.
Yes, I mean
So
default
yeah,
port boleh lah, Dr. Farhan. If it's you know it's apa ni, the classifier ni memang
yeah,
bertanggungjawab untuk classify locally je. We don't use
exactly.
it anywhere else kan. We don't use it anywhere else. But if you want to generalize the classifier, then I'm afraid
Yep.
using the port base tu won't help much lah. Kan?
Yes, I think we move forward. I mean, quite far already. So I
Kan?
think we have like another 10 minutes. Maybe you tell a bit about the grain and uh
Oh,
chains and so on, like the forest
okay,
classifier.
okay. Sorry. Oh, the grain tu is actually
Yeah, like 10 minutes. Yeah, yeah.
okay, it's actually my work. Actually, the solution that I've proposed, I've actually published the work. The work is called grain. Grain tu is just a name lah kan, granular classification. So what I did was in the grain classifier tu, I actually connected two machine learning classifiers together. Okay, I'll go very briefly lah kan. I don't go into details lah. So the first classifier actually classifies at the application level. Facebook, Twitter, Instagram, TikTok, Spotify, application je. Application. So the output from the first classifier tu, since that now we know, for example, we know that packet A is from Facebook. Okay, but we still don't know Facebook apa. Facebook comment ke, Facebook apa ke kan? Facebook, the services lah, we still don't know. So we take the output of the first classifier tu, we fit as an extended input to the second classifier. So yang tu lah classifier chain tu, we are chaining the classifiers together. So we use the output of the first classifier as an extended input. Maksudnya we have existing punya input, but we extend the input using the output of the first classifier tu. So the second classifier tu dia akan classify at the application service level lah. So why this works is because we are actually narrowing down or making the decision space to be smaller. If we were to classify application service at the very first level, then the decision space tu besar sangat. It can be Facebook comment, it can be TikTok comment, it can be YouTube comment kan. But if we dah narrow down that this is Facebook, so whatever it is, it should be Facebook. So we can classify whether it's Facebook comment ke, Facebook like ke, Facebook video ke. So that's generally that's all about lah.
I see.
Generally.
It's like a layers and you chain it together, all the
Yes,
layers.
it's chain it together lah.
So for everyone, it's a bit inclined. It's like, so you need to do the attendance via the link given by the committee, and also there will be like a quiz, and you will get like I think a special gift from the society for answering the quizzes, and it will be really good prize, I think. So
Yeah, there are prizes lah, I suppose. There are prizes.
yeah,
Ada hadiah lah.
yeah. And if you have any question, do put it in the chat space, and you can ask anything from Dr. Faiz Zaki about the research that's going on, and even generally about what happenings like in everyday, like we send messages, we send for example Twitter, Facebook, and so on, right?
Yes. All right. If
Yeah.
any of the audience have any questions, then you know, I'm happy. I'm happy to answer. Okay, ada ke? But if tak ada pun,
Please continue.
it's just ada. Oh, okay. Uh, it's just ni lah, sharing lah kan, sharing.
Mm.
that's actually what's happening lah with the network security punya domain. We are actually monitoring what's happening in the network. For example, in my workplace lah, in my workplace we have a um, security operation center lah, tapi tak ada lah macam dia orang grand sangat kan, kita expect ada screen besar macam dalam TV tu, tak ada lah. But the security operation center is actually monitoring the live network in my workplace. So we actually know what everyone is doing. Because the thing is, my workplace, we always receive reports that the network is always being compromised. Always being compromised untuk all sorts of things lah, kan, untuk all sorts of things. Okay, so but we have previously we have very limited way, or in fact no way of tracing back this the source of compromise ni. So what happened is we built our own SIEM lah, Security Information and Event Management punya platform. So from that CM tu, however you pronounce it lah kan, Security Information and Event Management tu, we managed to actually map balik lah the traffic dengan the originating source and what the individual is using, what application, what service. So in a way, when there is a compromise, okay, we can easily track balik lah the point of compromise tu. Then we can actually reach that compromised individual. Maybe dia orang ni tak sedar pun. Dia orang ni tak sedar pun what's happening. Kan?
Yes.
Maybe they downloaded something ke, so we can actually inform them lah.
Inform them and notify and ask lah. Right.
Yes.
There's a question, from Nordin Ramli there, and the question is, Dr. Faiz, does it create another delay or complexity due to the chaining of the classifier? If you put it in network, I believe. Yeah.
Yes. Of course, they have a slight delay lah. But we have addressed that actually. Sebab memang that's the first thing that akan pop up lah kan. Because when we chain ke, or in fact, if whatever activity yang kita buat pun, whatever task that we do, if we actually plug the traffic out, then it may cause lah, highly likely it may cause some sort of delay or latency. But the thing with that with the grain punya solution that I propose to is actually memang we aim it to be real time. We aim it to be real time in a way that the statistical features tu we only pick for the first few packets je. We don't actually wait until the connection is complete, tak. So so secara literal dia, complexity yes, slight complexity lah, orang kata negligible complexity lah, complexity pula, sorry, negligible delay lah and latency. Because we the feature extraction tu memang intended to be real time, so we limit our feature extraction to be only for a few packets je. That's how we address that problem lah.
Okay, right. Thank you very much, Dr. Faiz. My last question, what's the way forward for green? Do you have any
Yes, way forward for green is like I said just now, we are moving towards real time kan. But the current solution tu adalah still some limitations here and there lah, macam for instance it can be faster. Okay, it can be faster, and if we were to apply in a very specific domain such as IoT, for example kan, IoT punya network, you know that IoT network ni is very resource constrained kan, very resource constrained. It has to be lightweight, it has to be the complexity has to be really low because it's IoT kan, IoT is very little devices ni. Yes. So we are working towards that. We are working towards lowering the complexity even further and maybe distributing the process lah. Sebab tu during my introduction just now, your introduction of myself tadi, I mentioned actually my current work is moving towards federated learning semua tu kan. Yes. Federated learning tu is a distributed kind of learning lah, where everyone contributes to the global model, so to speak. So we are moving towards that lah. We are moving towards achieving a quicker classification, a faster classification. right, to address the more demanding network environment landscape these days.
Okay, thank you very much, Dr. Faiz, for a very insightful world of data packets.
Yes, yes.
The next time I'll be in UM, I'll be careful what I like and what I commented on Facebook.
True,
I mean, your
true,
network. It might be monitored by you. Okay.
true, true, true.
All right. Thank you, everyone, for this lovely morning session. And it's almost like 12 p.m. And we look forward for the third series. And now it's the second series. And you can access the video, basically, on the Facebook pages of the RTPE Communication and Vehicular Technology Joint Chapter Facebook. And the third one going to be taught by Mr. Azlan Muhammad Ghazali on cloud security, and it will be tomorrow on 19th October. I think the same time, right? 11 a.m. to 12 p.m. Yes. Okay, look forward to see you again tomorrow and have a good day. Thank you,
All
everyone.
right. Thank you. Assalamualaikum.
Salam.